Welcome to Code. So in this episode of the LeetCode series, we are going to solve a question called valid perfect square. It's a very easy question. As usual, let's get started by reading the question, trying to find an algorithm, and then get into LeetCode and coding that algorithm. So without further ado, let's get started. So given a positive integer num, return true if the number is a perfect square or false otherwise. I told you it's simple. A perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. And we cannot use any built-in library functions like square root. Okay. Now, with this information, and as we all know what a square root is. A perfect square is a number like 25, 9, 16, which we get by squaring any of those integers, like 4 square is 16, 3 square is 9, and 5 square is 25. So all of these integers squared gave us those numbers. But for example, the element 14 is not a perfect square because 3 square is 9 and 4 square is 16. We do not have an integer between 3 and 4, but 9 and it always goes until 16. 3 square is 9 and 4 square is 16. 14 lies between 9 and 16, but there is no number or an integer between 3 and 4 whose square gives us 14, and hence 14 is not a perfect square. Our job is to find whether the given number like 16, 14 and 10 is a perfect square or not. If it is a perfect square, return true. If it is not a perfect square, return false. So let's get to an example with the number 16 here. So if num is equal to 16, the obvious or easiest approach would be start from 1 until 16, whether 1 square is equal to 16. No, move on to 2. Whether 2 square is equal to 16. No, move on to 3. And similarly in the fashion, we can go away until 4. We'll get 4 square is equal to 16 and hence we'll get our answer. This was an easy question, but if we get a complex number or a very large number, in that case, using this linear approach would take a lot of steps, and that is not a very efficient approach to solve this question. So, in order to find a more efficient approach, we are going to use the binary search. Why binary search? Because as you can see here, 1 to 16 is sorted, and hence we would have to just find a number between the 1 and 16 such that the number square is equal to 16, right? So that is where binary search comes in. Okay, so let's get started. What would happen if we use this same logic to convert it into binary search? So instead of 0 to n, we can just use 0 to n by 2. Why is that? As you can see here, any factor of a number, like for example, all the factors of 16 stops at 0 to n by 2 other than the number itself. So for example, what are the factors of 16? 2, 4, 8. And all of these are less than n by 2, right? I'm just not including the value 16. 1 is also a factor, but as we know, 1 is a factor of everything. So I'm ignoring that as well. So if you take any other number, for example, 15, the factors are 1, 3 and 5. And all of these are less than 15 by 2, which is 7.5, right? So there is no number which is greater than n by 2 and is a factor of the value given n. Okay, and hence we can just limit our search to 0 to n by 2 here. So let's start with it. We have 1 to 8 and our mid value is nothing, right? So 1 plus 8 divided by 2 will be our mid value, which is 9 by 2, and 9 by 2 is 4. 4.5, but since we are doing 4 here, we'll get the value of 4. So 4 times 4 is equal to 16, and that is our answer. We just got it in a single step, and that is the power of binary search. Let's move on to any other example. For example, num is equal to 14, and as we know, it is not a perfect square and we have to return false. So how do we come up with that? So we have 1 to 14, but we can stop until n by 2, right? So we have just until 1 to 7. So 1 plus 7 divided by 2, that will give us 4. And 4 square is equal to 16, right? It is not equal to 14, and hence we have to shrink this range of values from 1 to 7 to just 1 to 3. Why is that? If 4 square is 16, then 5 square, 6 square and 7 square will obviously be greater than 14. We know that 16 itself is greater than 14, then 25, 36 and 49 will obviously be greater than 14. So we don't have to search 4, 5, 6, 7. We can just search between 1 and 3. If there exists a solution for this, it would be in this range of values, right? So we have narrowed it down. Now we have just 1, 2, 3. Again find the mid value. 1 plus 3 divided by 2, which gives us 2. 2 square is 4. And as we know, 4 is not equal to 14. We know 14 is greater than 4. And hence, the value must be to the right side of 2 or greater than 2. Because 1 square is 1, which is less than 2 square, right? So it can't be in the left hand side. So we are eliminating those two values. Now we are just stuck with 3. So 3 plus 3 divided by 2 will give us 3. And 3 square is 9. So 9 is less than 14. So the element must be greater than 3. But what element do we have? We don't have any elements to the greater than 3. So finally we see that there is no element left with us, and hence there is no element. That square gives us 14, and hence we will return false. So this is going to be the algorithm that we are going to use, a binary search algorithm. So left is equal to 1 and the right value is n by 2. We apply a binary search with left, right, and the value that we are searching for, other input that we are giving is n. Okay, so we'd have to find the square root of n if exists. If not, we'll return false. Okay, so we'll apply this binary search. It will do the process as we saw earlier again and again. If it finds an answer, we'll return true. If it does not find an answer, we'll return false. So and that is going to be the approach that we are going to use here. So I hope you've understood this logic. Now let's get to LeetCode and code this solution. As we saw in the pseudocode, let's first get started by declaring the values of left and right. We know the value of left is equal to 1 and the value of right is equal to n or num divided by 2. Okay, so with that out of the way, let's get started. So we'll use the iterative approach of binary search. We also have the recursive approach, but here it's easy enough to implement the iterative approach itself. So while left is less than or equal to right, continue this process. So what process is that? Finding the mid value. So it is going to be left plus right divided by 2, and after finding the mid value, check whether mid times mid is equal to the number that we are searching for, which is num, right? Okay, so a warning here, we are going to get a problem in this part of the code. I'll explain to you the later part of it, but we are going to check whether mid times mid is equal to num. Okay, so if it is equal to num, in that case we would return true because we have found the answer. There exists a value mid whose square gives us the question, right? So we have found the value, so we'll return yes. But if not, then in that case, if mid times mid, we can just store this mid times mid in a value. Okay, so int let's call it sq. Okay, mid times mid. Okay, and after all of this, we'll just use the value sq here. Okay, so if sq or the square is greater than mid, okay, sorry, greater than not mid, it is greater than our value num. So if it is greater than num, what does it mean? The square is greater than num. For example, we are searching for 14, but 4 square was 16. In that case, we don't need to search the values to the right of 4. Okay, so in that case, we would decrease the value of right. So right is equal to mid minus 1. We are shrinking the boundary. So right side boundary is being shrunk here. Okay, and now in the last case, we can just decrease the left boundaries by mid plus 1. Okay, and at last, if we didn't find an answer, we'll go out of this while loop, and in that case, we'll return false. Okay, so let's run this code and we'll get an error for sure. And when you submit this code, and at that time, I'll tell you what the error is. Okay, so now it works for the test case 16 and 14. Now I'm submitting this code and we'll get an error. Yeah, as you can see here, we are getting wrong output for 1. Okay, so wrong output for 1, right? Yeah, I forgot to mention that we first have to check whether the num is equal to 1. If it is equal to 1, we can just straight away return true because 1 square is 1. So it's a perfect square, but for the rest of the things, we can just apply this logic. Okay, and that was the error, but that's not the actual error that I was talking about. Okay, as you can see here, 808201, right? For this question, the actual answer is true, but we have returned false. If you notice what the problem was, here this is a very big number, and when we take the range of integer, it's pretty small. And when you square that, for example, when you square 32,000 by 32,000, you get a very big number, right? In that case, it can't be stored in an integer, and integer overflow occurs. Okay, so in that case, what we have to do is we have to convert this into long. Okay, and we'll just add a value of long here so that we don't get any errors with this. Okay, so now if we try to run this, now since we have converted it into long, we will be able to store that very big values that we get when we multiply very large numbers. Okay, so now we have got it accepted. So this is how we solve this question called valid perfect square. So if you like this video, please drop a like and comment down below if you have any questions, and don't forget to come on next week for another episode of the LeetCode series. Until then, bye bye.